Right, grade 12. Let's go into a matric situation and let's look at what they ask in matric on trig graphs. Well, what I'm going to ask you to do is from the interval minus 90 to 180, I want us to draw the graph of fx is equal to negative tan x, have a bash at that, and then I want you to also sketch the graph of, for me, gx is equal to sine 2x. Now we've already sketched these, so this is pretty easy. Sketch that, and then I'm going to deal with some interpretation type questions based on these two graphs. Okay, so let's have a look. In fact, we could do it together. Let's have a look here. If you take this graph of negative tan, how did that go? Well, remember there's asymptotes at 90, 270 and negative 90. So let's put those asymptotes in. And if you remember negative tan, if you go to 45, it goes down to negative 1. So there's a point there. Okay, there's a point there. And so the graph would come down like this. Goes there and still has a period of 180 degrees there and comes down like that. Okay, awesome. So that's the graph of there. And then of course this point, if you take minus 40, add 180, you get that. 0, add 180, you get that. And this graph comes like this. It comes down, decreasing all the time. Let's put an arrow to show that it came from there. So that's the graph of f. Now the blue one, let's have a look at this. The sine of 2x, if you remember, the period was 360 divided by 2, which is 180. And if we divide 180 by 4, we get 45. So this goes up like that. It goes from there to there to there. The period shifts. So the sine curve, sine 2x, very much like the graph in the previous lessons. We'll just put it there. And this comes like that. Okay, there we go. Alright, so this is the graph of G. I'm just going to put little G's over here. And then if we go purplish, there we go. This is the graph of f here. Okay. And so we go and let's put an f there. Now I'm going to ask you some interpretation type questions on this. Typically in the spirit of the way they ask it in the matric final. Okay, now I want to keep those graphs there. And the very first question I want to ask you, this was of course A, so we'll call this B1. Okay. I want you to determine graphically the values of x for which, now watch this, determine graphically the values of x for which fx is equal to gx. Now that is where the graphs intersect. Well, where do they intersect? There and there. Okay, so the solution to this would be at x is equal to 0 degrees or x is 180. Where does fx equal gx? Where their y values the same, where are they intersecting? So that was pretty straightforward. The second one is where is gx, for which values of x is gx greater than or equal to fx? Now let's just translate that into English. It says where's the blue graph? Okay, so where's the blue graph above the purple graph? Where's the sine curve above the tan graph? And where does it cut? Well, let's see. If we go and isolate that, okay, where is the G graph above the purple graph? Okay, well, if you come from minus 90, you can see that the sine graph is always below the purple graph. Now, if you go from 0 to 90, the blue graph goes above. But remember, at 90, this purple graph, the tan graph, doesn't cut the asymptote. So if we're above, we're going from 0 to 90. Okay, so that will go like this. Alright, so we're going to go 0 is less or equal to x is less than 90. Notice we're not including the 90. But now remember, this is above or intersects. Because if you've got an equal sign there, it means intersects, where it intersects, where it cuts, like this one. So it's above or cutting. Now, if you look at this carefully, the blue graph is above the purple from 0 to 90, but it also cuts at 180. So many matrics forget to put the x is equal to 180 degrees as well in. So there's two possible answers here. Where it's above is from 0 to 90. Where does it intersect? At 0 and at 180. See there, at 0 and 180, it intersects as we've got there. Alright, and then the third one that they love asking is they'll say to you, where is the fx graph less than naught. And simply put in English, is below the x-axis. That's where the y values are negative on that graph, where the y value is negative. Now where's fx? Let's have a look at fx. Is the tan graph. Where does it go below? Well, it's going below. The tan graph is definitely going below from, if you think about it, from 0 to 90. Okay, from 0 to 90 it's below, and that's it. And notice that they're not saying here, they're not saying where does it cut the x-axis. So where's the graph of f? Below. Very simply, it's below from 0 to 90. Okay, so that's 0 to 90 there. So you can say from 0 to 90. That's where it's below. Okay. And the next question, let's have a look at this. Number 4. They could ask you, for example, where's the graph of g bigger than or equal to 0? That's above the x-axis. That's where the y values are positive. The y values are positive. So let's see where the sine graph is above. Okay, now have a look. Or above x-axis positive, or even where it intersects the x-axis, where it intersects the x-axis. Okay, so let's check that. If we go up to the graph of g is the blue, where's it intersecting the x-axis? At 90 it cuts there, and at 180 we've got those two. And where is that graph going to be above? Well, it's definitely above from 0 to 90. Can you see that there? From 0 to 90 the blue graph's above. So that's great. It's above the x-axis. The y values are positive, and also at minus 90 and 180, it's cutting the x-axis. The y values are naught there. So with this guy, we can say x is equal to minus 90 there, or we can go from 0 to 0 less or equal to x, less or equal to 90, or at x is equal to 180 degrees there. What a pleasure.